Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of isotopes and atomic mass. Well, what is an isotope? Isotopes are atoms of the same element that have different atomic masses. Now, if they're of the same element, we know that they have to have the same number of protons. But they do differ in their number of neutrons. So, for example, when you see C12 and C13, that's what that's talking about. They're stable isotopes in nature, mostly of carbon-12 and partially of carbon-13. Okay? So, what happens here is these are individual atomic masses, the 12 and the 13, and they show up at fixed proportions or fractions of all the carbon in the world. No matter where you were to go in the world, if you find some carbon and you examine their atoms, you would see a fixed ratio of carbon-12 versus carbon-13. Now, this doesn't affect Dalton's theory at all of atoms. The behavior of both of these isotopes is virtually identical. So, what we see when we look on this periodic table here is an average of those atomic masses. So that 12.011 there is taking into account the fraction of the carbon-12 times the mass of 12 plus the fraction of the carbon-13 times the mass of 13. And as you can see, the proportion is drastically in the favor of carbon-12. That's what allows us to get that average atomic mass. So we keep throwing around this word atomic mass. What is atomic mass? Well, it's exactly what I just said. The average of the mass of the naturally occurring isotopes. This is what you're going to find on the periodic table. It's also referred to as a molar mass. Once we discuss the concept of moles, we'll go over the concept of molar mass as well. Now, don't confuse atomic mass with protons plus neutrons. That's the mass number. Okay. Here we're talking about the average of the atomic masses of all the naturally occurring isotopes. So how does this work? What's the concept? Well, the isotopes, like I said, only show up a fraction of the time in each sample of carbon or whatever we're discussing. So the basic formula is the summation of the fraction that it occurs out in nature, or this could be a percentage as well, times the weight of each one of those added together is going to give us that. Ooh, that should be average atomic mass. Sorry. So, for instance, if we have two isotopes, A and B, this could easily be the carbon-12, and this would be the carbon-13. It would be the fraction of carbon-12 always found in nature times the weight, which in this case would be 12, and you would add it to the fraction of carbon-13 times 13, and that would equal the average atomic mass of 12.011 in this case. The only difference if I use a percentage here and here is that whenever I do percentages, you need to multiply by 100 here. Okay, that's only if you're doing percentages. If you're not doing percentages, it would be a 1 because we're talking about fractions of a whole. All right, so there's a couple ways these problems can be given to you. You can either be given both the fraction and the weight of each isotope, and you just multiply and add them together to get the average atomic mass. Or you might be given the percentage, do the same concept. Finally, they might give you the average atomic mass, the different weights, and ask for the percentages. Those are the three types of problems you might see. There will be an example video for each of those, so make sure you check that out. Practice, practice, practice. Thank you, and have a nice day.